Okay, so now let's see the part B question 2. So C program to generate an asymmetric square wave of 120 Hz and having a duty cycle of 25% using timer 0 module. So in this we require some basic calculations first, which may be over here. We assume the system clock to be 60 megahertz, not assume. We will see that in the later keel execution, where we'll find out how to set this clock and stuff. And then the required frequency is 120 hertz, and we say that peripheral clock is one fourth the system clock. So after doing some calculation, we get the n value, and that n value over here we get it as 124,999, and that we can convert into hexa like after multiplying, because we need 25% of the duty cycle, so we can multiply it into 25, and we get this value. This frequency calculation is there in one in the textbook, so you can refer it. Okay, so let us start keel first, and then create a new project, say timer, and then select LPC2148. Yeah, so here you can see CPU clocks up to 60 megahertz, so we can change it later on. And for this we need a startup.s file because it's a C program. And let's create a new file first and put in the basic stuff for LPC2148. And the main function, and let's save this file so that we get syntax highlighting. Say again timer 0.c, and now we first put t timer 0 match control register, and we set this value to 0x4. It says that it stops when the match is found. When the timer and the match registers match, it stops. Then we select IO pin. We don't select IO pin, we just make one of the output, one of the pins as output, and let's say pin number 16, port 0, pin number 16. So here we have to put in a 0, and then for the wave, put in an infinite loop, that's while 1, and in the loop we first say that IO set 0, the same pin which we have put as output, and then put a wait function, and then clear same pin. So this less than symbols are the bitwise shift left. So if the same thing shifts around for 16 bits, we get the 16th pin, so we don't have to put a hexadecimal value. And then put a off wait function. So now let's define these functions. Close the while loop and let's define these functions, and it will be like void on wait. We set the timer 0. Let's use match register 0, and set the values from the calculations, say 7A11, 7A11, and we enable the timer. We start the timer basically using T0 timer controller register, and then equal to 1. This starts the timer, and then we put a while loop checking whether these both are equal or not, which is the timer 0 timer counter and the timer 0 match register 0. And at last, before exiting, we stop and reset this timer so that for the next wave it starts from 0 again. So let's copy the similar function for off wait over here, make this off, and this value we can take from this calculation to be 16E35. So 16E35, and we are done with the basic program. Okay, so let's add the timer 0.c into the source group. Add existing file timer 0.c, and there it's added. So let's rebuild all files, and we have some errors. So it's not void main every time, it's int main, and at last you have to add a new line. And if you compile again, you get 0 errors, 0 warnings. And now you start the debug, and I think we don't need the disassembly over here right now, and register window too, maybe the project also. Start the logic analyzer from here, and setup, we have to see for port 0.16, and make sure it's in bit always. And we okay, now so we click run to cursor line, and it starts drawing this thing. We can zoom it out. Let's check out the frequency. Just click at the start point and go to this point. You get 23 hertz, which is not expected. We need 120 hertz. So what we do is go to peripherals, system control block, phase lock blue, and here we change the value to 60. And after setting it to 60, you can reset everything and then rerun to the cursor line. And then this time, when you see from the first point to this point, it's 119 approximately. If you take correctly, you will get 120 hertz. Under the delta section, you can see 120 hertz, and that's what is expected. And 25% duty cycle, because we have calculated it.